in probability today. Let's take a look at a situation. There are 1,596 students at Tarpon Springs High School. %58 are female. 22% of male take an AP course. And 38% of female take an AP course. Question 1. What is the probability? Oh, I'm sorry. We're going to assume independence. What is the probability being a male and an AP student? Well, the probability of being male, there are 58% that are female, so if I take 100% minus 58%, I have 42% are male. AP student, 22% of males had taken AP course, so we do that right there. We are going to assume independence. That means we can multiply. So 0.42 times 0.22, which is 0.0924. And the notation, male and an AP student, is male, M for male, intersect, so M for male, AP student, so A would stand for AP. And we get 0.0924, or 9%. Question 2. How many female non-AP students are there? Well, we have 58% that are female, and 38% of the females take an AP course, so not AP course would be 100 minus 38, which is 62. And we can make that a decimal, so 0.58, 0.62, and we can multiply because we're assuming independence, and we get 0.3596. But that's not what they asked. They asked how many. So 0.3596 times 1,596 is 573.9216. Well, I can't have partial people. So 574 female non-AP students. About. Okay. Number 3. Probability of being an AP student. This is where a tree diagram might help a little bit. You may not have to use it. Definitely will be helpful when I show you number 4. But we have female and male possibilities. In the female, there are 58%. So males have to be 100 minus that, or 42%. And we have AP and non-AP. and 38% of the females are AP, meaning 100 minus that is not AP, or 62%. 22% of males are an AP student, meaning 100 minus that, or 0.78, are not AP students. We're assuming independence, so we can multiply like 0.58 times 0.38, or 0.58 times 0.62, so on and so forth. We want to know AP students, so okay, we got females, only AP, and males, only AP. Well, we can multiply 0.58 times 0.38 is 0.2204. 0.42 times 0.22 is 0.0924. And we want to know total how many AP students, proportion. So we add those, 0.3128. So the probability of being an AP student is 0.3128. Now, this is where it's definitely important for you to use a tree diagram. And so let's take a look. We're going to look at what is the probability of being female given the fact they are an AP student. So what we are looking at is probabilities within probabilities. So anytime you have those probabilities within probabilities, it is definitely helpful to use a tree diagram. So we look at given, that means conditional probability. The condition is AP student. So we look at only the condition. So we only look at AP student. Well, that's what we just did on number 3. Here's the condition. So we're only looking at AP students, which is 0.3128. Out of that condition up there, how many are female? Because that's what we're looking for. Okay, not the 58%, that's out of everything, but only out of the condition of AP students. So that's 0.2204. So you divide those, 0.2204 divided by 0.3128, and we get 0.705. Okay, hopefully this helps you out a little bit on some basic probability, some probability with tree diagrams, and conditional probability. Good luck. So that was the wonderful world of tree diagrams and basic probability as well as conditional probability. Remember, if you have probabilities within probabilities, you probably want to make a tree diagram, and then you can see some of those conditions. Okay, good luck.